Okay, welcome back, everyone. So today we're going to be doing the second example, which is this. And like I said, it's going to be much easier than the previous one because all it involves is a midpoint argument, actually similar to one that we partially talked about um, in the first video on real analysis, um, which just introduced Infimum and Supremum. So, well, how do we continue here? Well, first, a natural thing to do is to factor this quadratic. And, well, there's a pretty easy factorization. And again, to see why that's useful, it's because we're finding when this is less than 0. And recall that, well, what we're trying to do whenever we factor an expression. So let me just write out the factorization. Let's just first set it equal to 0. So what are we doing when we find the zeros? Well, suppose our quadratic looks like something like this. Okay, so let's say these are the zeros when when our quadratic crosses the x-axis. Well, notice that we can actually just use these bounds to find when this quadratic is negative. Since it's a quadratic, it can never, well, since it's a function, it surely, therefore, it satisfies the vertical line test. It can't like go some wonky way like this. That's impossible. So therefore, we have that. We can, once we find our zeros, we can just use those as the bounds for this little set here. So, well, what values satisfy this? Well, that's clearly just x equals -4 and -1. So in other words, we can just transform our set S2 into the following set. Just x ranges from -4 to -1, where x is in Q. Now it's important to note that x is in Q, otherwise this problem would be much easier if x was not in Q. If x was in the natural numbers. Okay. Well, let's see. Well, the supremum, let's start off with that. So if we kind of want to graph this a bit, just to get an idea of what we're doing here, let's say 0 is somewhere here, and this is -4, this is -1, okay? And we want to show that the supremum of the set is -1, namely the sup of S2 is -1. So therefore it suffices to show that given any a in how should I do this? Given any a in S2, there exists a prime such that I should say a prime in S2 such that a prime is greater than a. Okay, if we can show that, then, well, we're good, right? Because then it can't be true that we have a supremum that's inside of that's inside of our S2. Okay. So, well, let's see. And actually, again, using the midpoint argument, just take a prime to be a minus 1 over 2. Now, let's show the following. Let us show that first a is less than a minus 1 over 2. Well, notice that this is true. We can just write a chain of if and only ifs. So equivalent statements. So we have 2a is greater than a minus 1 if and only if a is less than -1. And this is a true statement, therefore this statement is true. Right, this is true because by definition of a being an S has to satisfy that. Okay. Well, now let's show that a minus 1 over 2 is less than -1. Using the same if and only if chain, you have a minus 1 is less than -2. if and only if a is less than -1. Another true statement. Okay, so that proves that the sup of S2 is -1. Now let's show that the inf of S2 is -4. Okay, how do we show that? Well, again, using the same idea, given, I'll just write for all b in S, there exists b prime in S such that b prime is less than b. So there's no infimum. In other words, there's no maximum of the set. There's no infimum inside the set. Okay. Well, let's see. So we have, so we just have, okay, again using the midpoint argument, we're just going to take b prime to be equal to b minus 4 over 2. Let's show that b minus 4 over 2 is less than, b minus 4 over 2 is less than b. So that's true if and only if b minus 4 is less than 2b is true if and only if minus 4 is less than b, which is true by definition of our set. So therefore this is true. And finally, let's show that b minus 4 over 2 is greater than minus 4. So that's true if and only if -8 is less than b minus 4. It's true if and only if minus 4 is greater than, is less than b, which is true. Okay, well that completes this problem. And notice that since, again, the infimum and the supremum are not inside of S2, then that tells us that this set has no maximum and no infimum. Okay, well that completes this video, and finally we're going to go on to a famous example in the next video. See you then.